Hello, Python coders. So in today's video, I want to talk about something that I mentioned in one of my previous videos, and that is object-oriented programming when dealing with GUI frameworks in Python. Now, what I'm going to show you here references PyQt PySide, but it's also applicable to other GUI frameworks such as WX or Kiwi. Python is an extremely interesting language because we can create top-down or procedural programs very easily. For instance, we could write a simple program that brings in data from a database and turns it into a CSV or an Excel spreadsheet. Those types of things would be a procedural style program. Read in data, change it, and then output it into another format. However, surprisingly enough, even though we are creating a procedural program in that case, we are working quite a bit with objects. We're not creating any custom classes in that case, but we're still working with objects nonetheless. For example, let's take a look at some code. I'm going to create a variable called first name, and I'm going to put my name inside that variable. Then I'm going to print my name out, or print out the contents of that variable. And also, I'm going to print out the type that variable is. And I actually need to put in the variable name. It should be first name. If I run this code, what you're going to see is it prints out my name, because that's the contents of the first name variable. If I print out the type, it's telling me that it is based on the class string. So really, even though it doesn't look like it, and I didn't have to declare it, because like in other languages, I would have to declare what type first name is. I didn't have to do that here. All I have to do is say first name equals JSON. It creates a string object based on the string class and puts in the contents for me. A lot of those things are going to be hidden within Python. It's one of its best points as far as I'm concerned, is a lot of that bit twiddling is hidden for you. Also, you may hear the term, if you're a newer Python developer, you may hear the term variable is variable. And in Python, that's extremely true. I can take this first name and I can also set that to 25. So now if I copy this code to print that out, what you'll see, if I could do that right, if I copy this and then paste it, what you'll see now, if I run this code, is we get our JSON and our string class, but then you'll see that it prints out 25 from up here, and also the class has changed. It's changed to an integer class. What happens is Python under the covers throws away the first instance of the first name variable, creates a new one based on the integer class, and then puts the value of 25 in there. All of that is happening under the covers. I don't really have to be that concerned about it at all. It's great, and it also does have some limitations. In other words, you could actually accidentally clobber a variable with an integer value when it was a string. But for the most part, if you're careful, that doesn't happen. And this is one of the strengths. Now, we didn't create any custom classes. And we can also utilize methods that are on these objects. So if I create a list of names, and I'm just going to create a list, and then I'm going to use a method attached to the list class called append. So I can say names.append, and then I can put in my name. I can also add another one. And if I print out the names list, what we should see is Jason and Rick. So what I'm doing here for my names list is I'm using a method that's built into the list class called append. And you saw in my code editor, when I type in the word names, dot, here's the whole bunch of methods that are attached to that class. You'll see they're attached to the list class. Copy, count, sort, clear. These are all very useful. Okay. But I'm not creating them. They're built in and they're part of the language. So because I'm not creating a custom class, I can sort of get away with thinking that I'm not really doing any object-oriented programming. And yeah, technically, because you're not actually creating any new types of classes, but you are utilizing existing classes. So let's take a look at an example that we're going to build upon here. And we're actually going to create a custom class. The class that I'm going to define is called animal, and it's going to take in two arguments. One is name and age. Self will be passed in automatically. What is self? Well, self is a reference to, sort of a placeholder, for the actual object that we are going to create. So whenever I see self, it means this instance or this copy of the object that I am working with. So when we create our animal one, based on the animal class, we are going to be passing in a name, which is defined here, and an age, defined here. The first thing I'm going to do is I'm going to make these properties of this class. So I'm going to assign them to self.name and self.age. You'll notice that the object name is passed under the covers for me. So I don't have to worry about passing in animal1 as the first parameter. That's going to get taken care of for me automatically. And then I'm going to print out my name is name, I'm years old. And the method that I have created for this is a special method called the initialization or the constructor method. And it begins with double underscores, ends with double underscores, and commonly what you will see is these are referred to as dunder methods because they have double underscores. So dunder is just short for double underscore. When I create an instance of this class, in other words, my animal1 right here, this is ran for me totally automatically. I don't have to tell it run that method. It just runs for me. I've also added two other methods, getAge and getName, which are going to return the age and the name for this particular instance of this object. If I had 14 of these, it would only return the one for the object I'm working with. And that happens right here. So in this particular print statement, I'm going to print out the animal's name, and it's going to be animal1. So under the covers, animal1 will get passed in to the getName method, and it's going to return that particular object's the property of name. A little complicated to explain sometimes, but once you get used to working with it, it's pretty self-explanatory. So I'm going to run this code, and you'll see that my initialization method was called automatically, and it said my name is Bubs, I'm 2 years old. And then when I print out the name of animal1, and I call that getName method, it prints out Bubs. Okay, this is the simplest example we have, which is just creating an animal class and then utilizing it. It's the same exact thing that I was doing when I was using the list function in our previous example, But this one I actually wrote myself, where list is built into Python. To build on this, let's talk about inheritance. So in Python, we can create classes that are very closely related to each other, and then we can inherit from them. So in this case, we have the exact same animal class. However, we're not printing anything out, but we are storing the name and the age. Okay. However, with the dog class, we're first going to inherit from animal. That means that all of the properties and methods that are inside animal will be available to us. And we're also going to pass in one extra parameter, which is breed. And then I've also added a function here, which is, or method, which is get breed. So I could call that on the animal that I create and get back the breed. And here I'm going to print out, hello, I'm a age, year old, breed, and then named. So you'll see that in my dog class, there is another line of code here, and that is this one right here, which is my super. Whenever you see super being used, that means call this method on my parent. And that particular method, we're supplying it, which is the initialization method. We do this in Qt, in PySide, in PyQt all the time. I'll show you the example later on, but this is an extremely common practice. So because I have a child here, I want to also call the initialization method of the parent, which in this case, I'm passing in the name and the age. So if I go ahead and run this code, you'll see it says, hello, I'm a 2-year-old German Shepherd named Bubs. That's because right here with the animal one that we're creating, I'm passing in the name, the age, and also the dog breed. And then I'm also printing out the get age of my animal one by using a method attached to it called get age. And you'll see that when I actually type this out, I say animal one dot, and you'll see that the get age, get breed, and get name methods are available to me. So if I change this to get name, okay, if we go ahead and run this, you'll see it prints out Bubs. So any method that's in the parent is also available to me in the child. And because we based animal one off of the dog class, and the dog class is based off of animal, all the methods in the animal class are available to us. We could have several different classes inheriting from each other, going up the ladder. And this is done in PyQt, PySide quite a bit. If I have a QDialog, then QDialog will inherit from QWidget, and then in PyQt, QWidget will inherit from QObject. So you just keep going up the ladder till you get to the top. And again, when I have a child, I need to make sure that I'm calling the initialization method of the parent. All right, so in our next example is fairly close. We're going to have a animal class again, but you'll see I've created a class called activities. And I don't have an initialization method in here because I'm not actually going to be passing this any data. I don't need anything to happen right when I create this, create an object based on activities. But what I'm going to do is I'm going to have a method here called print activity, and I'm going to pass in an activity type. When I do that, I'm going to print out some details based on what activity that I'm doing. Down here, I'm going to be creating a custom class called dog, which is going to inherit from both animal and activities. I have an initialization method again, and I'm going to pass in the name, the age, and the breed. And then what I'm going to also do is I'm going to call the initialization method of the parent, which is animal, and I'm going to pass the name, the age, and the breed. Okay? I'm going to create a new animal, animal1, based on my dog class. I'm going to pass it Bubs, the age of 2, and that he's a German Shepherd. And in this particular case, once I have animal1 created, I'm going to call that print activity method, and I'm going to pass in a value of swimming. When we run this code, you'll see that it prints out Bubs is a 2-year-old German Shepherd, which is the line right up here in the animal class. And it also prints out I'm swimming, which is actually coming from the activities class, which is right here. So what I'm doing is I'm inheriting from multiple places. And you'll see that in these particular classes, there isn't a whole lot of commonality between them. You don't have to be an animal to be walking or swimming. Okay, so they seem to be rather separated from each other. However, because I've created my dog class and I'm inheriting from both places, I'm actually sort of combining the two. So the methods and properties from both classes are going to be available to my dog class. And this happens in PyQt and PySide all the time, especially when we are using Python generated from Qt Designer files. So I wanted to illustrate this for you because let's go into a PySide application, PySide demonstration, and we're going to be taking a look at this demo form validate for, and I'm going to open up the demo form window, and let's see, I want my demo form window too. Okay, there we go. This is what's generated from the UI file outside of Qt Designer. And remember, we don't ever want to manually change anything that's in here. It generates this class name based on what was the object name that I gave the object in Qt Designer, the main window that I'm working with, either a dialog box, just a Q widget, or even a Q main window. And what it'll do is it'll prefix it with UI underscore. The method that I'm most interested in here is this setup UI method, because when this is ran, this is what's going to put all of my GUI elements inside of that window or form. Notice how this class does not have an initialization method or a constructor method. So when we inherit from this class, we're doing so because we want automatic access to this setup UI method. When we call this setup UI method, everything is ran and it sets up all of our GUI elements on our form. And how we do that is if we go back to demo form, here's where I'm creating my form object. So here's my demo form. It's based off of Q dialog, which is part of Q widgets. And I'm also inheriting from that UI W demo form class. And the reason that I'm doing that is because I want instant access to this self.setupUI. Again, what do? We use the super function to call the initialization method of the parent. And all of this is going to be ran right when I create the object. This is what is very critical right here, which is the self.setupUI. that will actually add all of the elements, the GUI elements, to my demo form based on QDialog. Then I put the rest of my application logic in here, which is my validators, opening a database connection. This is what I want my two buttons on the form to do. Then I set my focus to the ID field, and then I call self.show. Down here, I create my application object, because we always need one application object for there to be an event loop. Then I create a form. And notice how I don't have to put anything in here to show the form. And that's because inside of the initialization method of my demo form class, I have self.show. So if I run this, there's my form. So it created a QDialog for me, and then it went and ran that setup UI method through all of the GUI elements inside of the form, ran all of this, and then shows my form. This is extremely common practice. And this is why I say that Qt, both PySide and PyQt, are very heavy object-oriented. Everything within these frameworks is an object. In fact, you're going to get so tired of it, you're probably going to want to rip the Q key off of your keyboard, especially if you're hand coding in PyQt, PySide, because everything begins with the letter Q. One question that I have seen posted before, and I haven't seen it addressed very well, is, okay, why am I putting all of this logic inside of the initialization method? Okay, and I'll explain this. The first thing that we're doing here, we're adding all of the GUI elements. We've covered that. But then we start adding application logic. Things like, when I click a specific button, what do I want to have happen? Why do I do that in the initialization method? Well, the reason you do it inside of the initialization method is that once you click, or once self.show runs, the window is going to show. You are actually in the event loop at that point. So when you do that, what's going to happen is, when you show the window, you want all of the connectors here to be in place and working so that you can put events on the event queue. So when I hit the OK button, that's actually putting an event on the event queue. If I close the window by clicking cancel, well, that goes to the event queue, and then it knows that it can close the window, and then the window is destroyed. If I click the OK button, it knows that it needs to run the validate record function, and it's going to continue to run that in a loop until I actually click the close button. So there's nothing really in the code here that explicitly says start the event loop, and I guess really you could say that this is your ending of the event loop right here. But there's nothing that really says start it except for right here, this application.execute. There's the start of your event loop. All right, well, I hope I clarified a few things, especially in the object-oriented space, about working with PyQt, PySide. Once you're used to doing this, it's really not that bad. What I would recommend is, if you're new to object-oriented programming, I would suggest looking up some tutorials on it. There are some pretty good ones out there, much better than what I could do to explain object-oriented programming. There's a lot of different aspects to it. But when it comes to creating custom classes with PyQt or PySide, It's actually pretty straightforward as soon as you understand the mechanics of what you're doing. And again, like I've stressed before, don't change these files created with Qt Designer. Okay. Well, I hope everyone has a good New Year's. It's almost 2023. And other than that, happy coding.